All right, for today, we're going to talk about 112 notes, and we're going to start on page 21. We're going to focus on three things today: learning discrete versus continuous graphs, vertical and horizontal lines of symmetry, and reviewing our quadrants. Now, this section has like a group activity. We're not going to be able to do that because, we're on NTI. So I'm going to try to give you some brief understanding of all three concepts that we need to learn today. All right, to start off, the quadrants, if you look over here to the far left, the quadrants, the top right is the first quadrant. Here's the second quadrant, third quadrant, and fourth quadrant. So if I look real quickly, the first quadrant, A is the only point in the first quadrant. B is located on the x-axis. E is located on the y-axis. And if I look for the second quadrant, D is the only point that is in this second quadrant. The third quadrant down here, F is the only point in the third quadrant, and C is the only point in the fourth quadrant. Now, just as a quick review, A is at the point, and it looks like it's at on the x-axis of 5 and on the y-axis of 2, so that point is 5, 2. B is at, looks like the x-axis at 2, and on the y-axis it's at 0 right here, so 2, 0. And I'm going to do one more. Let's jump down here to F. On the x-axis, it is at -8. Meant to put that for 8, or F. F is -8, and on the y-axis, if I look across, it's also -8. So here's a quick reminder of quadrants and how to do a couple of points. All right, what we're going to talk about now is discrete graphs versus continuous graphs. And if you look at these four examples over here on the left, do you see how this graph, it looks like it goes here and it comes up and makes like an upside down U or a hill? That's a parabola, but there's no line that's connecting these points. It's just a group of points. This is called a discrete graph. This graph, again, is a group of points, but there's no line connecting them. So all four of these are examples of discrete graphs. This is an example of a quadratic. This is an example of an exponential graph, linear graph, and also a linear graph, but all four of these are discrete graphs. And these two over here that I drew by hand, this is an example of a quadratic, but it's continuous because it has a line that connects all the little points. As a matter of fact, you don't even draw the little points because the line connects them. Over here, this is an example of exponential. And again, it's a straight, or not a straight line, but it's a smooth curve. So that is considered continuous also. So here's the difference between a discrete and continuous graph. But I need to caution you, not every time you see a graph with a line is it continuous. For instance, and let me draw you a graph here. If I was selling t-shirts, I might draw you a line that looks like this. I sold the first one for 10 bucks, or I'm sorry, $10 to place an order for like shipping. One t-shirt might be $15. Two t-shirts might be $20 and so forth. 3, 25. Now, even though I drew this one with a line, this one is not continuous. It is discrete. And the reason why is, and I'm going to zoom in right here if I can. I have a point right here. If I buy 0 t-shirts, if I buy 1 t-shirt, if I buy 2 t-shirts, when I draw the line that connects them, I am saying, well, what about 1.5 t-shirts? Can you even sell 1.5? Can you even buy 1.5? So even though the line is there, I know that there's no points in between 2 t-shirts and 1 t-shirts. So because of that situation, selling t-shirts, I drew it as a line, so most people would think it's continuous, but is in fact a discrete graph because you cannot have the little decimals between 1 t-shirt, 2 t-shirts. There's no decimals between 2 and 3. You can't sell 2.5 t-shirts. So in a problem situation like that, even though they drew it as a line, it is not continuous. It is in fact discrete. All right, with these 5 graphs, we're going to talk about discrete and continuous, and then we're also going to learn about vertical and horizontal axis of symmetry. Now, again, this is supposed to be a group activity, but I'm trying to save us some time, and we can't do this with NTI, so hopefully you can still understand. First off, discrete versus continuous. Graph C is drawn with two straight lines. Now this is considered an absolute value graph because it makes a V, whether it's going up or going down, it makes a V. So that's called an absolute value, and that's actually coming up in the next section. But since it's drawn with lines, we would say this is continuous because they did not give us a word situation where we had to worry about like t-shirts I mentioned earlier. Graph E, it makes like an upside down U or a hill, but it's drawn with 5 points. And the points are not connected, so that is considered a discrete graph. J, again, is a quadratic, just like E. This parabola is going up, but since it's drawn with a straight, or I'm sorry, not a straight line, but connected all the dots, it's drawn with a line, it is a continuous graph. Q, also a quadratic function. It's a parabola, and since it's all the points are connected with a line, it is also continuous. S is very similar to C up here. It is drawn with two straight lines that make like a V. This is absolute value. And this one is also continuous. Now let's go back and talk about vertical and horizontal lines of symmetry. A vertical line of symmetry is if I can draw a line straight up and down, and it's the same on both sides, it's a mirror image, then it is then it has a vertical line of symmetry. So let's zoom in here on C. I can draw a line straight up and down right here. And that line would be x equals 0 because it crosses the x-axis at 0. And it is exactly the same mirror image on the left side as it is the right side. They are mirror images of each other. So this one has a vertical line of symmetry. If I scroll over to E, again, if I can draw a straight line up and down and it's the same on both sides, then it has a vertical line of symmetry. And again, I think I can draw one right here. And that equation is x equals 0. Again, because this line goes straight up and down and it crosses right there on the x-axis at 0. I'm going to look over here at J. I can draw a vertical line again. That equation for that red line is x equals 0 because it crosses at the x-axis at 0. And if I look down here at Q, I can draw a vertical line straight up and down right here. So this one also has a vertical line of symmetry. But this one has not x equals 0 this time. It's not x equals 0. Okay? The equation crosses right here at -2, -4, -6, -8. It crosses at -4. So the equation for this line of symmetry is x equals -4. All right, now in the years past, this one has always confused the students because one line is drawn shorter than the other. But we need to remember that these arrows go on forever. So I can continue to draw this line up, 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 up forever and ever and ever in both directions. So when I say, does this have a vertical line of symmetry, a lot of kids get tripped up because it's not drawn like that. And they can look at it and say, well, one side's longer than the other. Well, that's not really true. The line goes on forever. So I'm going to look and see if I can draw a vertical line of symmetry. And I can draw one right there. And again, I'm trying to figure out the equation. X equals, it doesn't cross at 0. Let's see, right here is 2, 4, 6, 8. And it crosses right here between 2 and 4. So it crosses the x-axis at 3. So this one has a vertical line of symmetry at x equals 3. So looking back, all 5 of these graphs had a vertical line of symmetry. All right, now we're going to take a look at the exact same graphs and see if it has a horizontal line of symmetry. Horizontal line means going straight across. So can I draw a line going straight across and it looks the exact same on the top and the bottom? Well, if I drew a line right there, it does not look the exact same on the top and bottom. If I draw a line right here, it does not look exact same on top and bottom. It would have to look like this for it to look exactly the same on the top and bottom, but it doesn't. So graph C does not have a horizontal line of symmetry. If I go over here, if I could draw a line anywhere horizontally, it's not the same. I have 3 points on top. I would need 3 points on the bottom, but since I do not have those right there, I know this one does not have a horizontal line of symmetry. Over here, I cannot draw a horizontal line and it be the exact same on the top and bottom, so this one does not have a horizontal line of symmetry also. Q, no horizontal line of symmetry. and S. There is no horizontal line of symmetry no matter where I would draw it. So I'm going to show you this one because this one does have a horizontal line of symmetry. If I take my time and I draw a line going straight across right here, it is exactly the same above the purple line and below the purple line. They are mirror images of each other. So this one does have a horizontal line of symmetry. Now the equation for this purple line is not x equals because it doesn't cross the x-axis. Since this one is horizontal, it's going to be y equals, and it crosses right here at positive 2. So that equation is y equals 2. Now the final part of these 5 graphs is we were going to review the quadrants, because again, this was supposed to be a group activity and I was going to say, hey, place these in groups. Why did you put them in these groups? And hopefully one of you guys would have noticed quadrants here. And the reason I'm saying is graph C, the lines are only in the first 2 quadrants. Graph E, this point is in the first quadrant. This point is in the second, fourth, and third. So graph E has points in all 4 quadrants. Graph J has a line in the first quadrant and the second quadrant. Graph Q has the fourth quadrant. Or I'm sorry, that's not the fourth, that's the third quadrant. And also the second quadrant. Now, if I continue this up, it may cross over, it may not. It depends on if it's an asymptote, and you guys probably have no idea what that is right now, which is fine. But since I can only guarantee that it's going through the third quadrant and the second quadrant, I'm just going to say those 2 only for right now. Now graph S over here, it's in the first quadrant right here. This part is in the second quadrant, and this part down here is in the fourth quadrant. Messed up and wrote a 3 there. Fourth quadrant. It does not hit the third quadrant at all. So that might be something that you could look at and say, hey, these have something in common with each other. For instance, graph J and graph C only travel through the first and second quadrant. But if you throw in Q, you would say all 3 of them only go through 2 quadrants. Graph S is the only one that goes through 3 quadrants. And graph E is the only one that goes through all 4 quadrants. All right, your homework tonight, we are going to talk about page 37, practice problem 1 to start off. And there's 4 parts of it. So for instance, 1A has which graphs have a vertical axis of symmetry. You might say, and you could just write it on your paper, you might say graphs A, B, C, D, E, and so forth. Now, that's not the right answer, so don't put that as your answer. But you could simply just write it on your paper and then enter it into Schoology later. After you do practice problem 1, we are also doing review problem 1, 2, and 3. And again, I want to zoom in on number 2. Number 2 is very important. That's something that should be easy for you. If it is not, please let me know immediately so I can help you with remembering how to do it. Thank you and good luck.